We are the Kent State University Drone Team. This is the second year this team has existed on Kent's campus, but our first year participating in the AUSVI SUAS competition. The goal this year has been to create a strong foundation for the team to continue building on for future participation in this competition. Now it's time to meet our competition team. This is Kendi Edmonds. She is the competition RPIC, payload operator, and team captain this year. She received her undergraduate degree from Kansas State University in UAS flight operations and has her manned pilot's license. She is now attending Kent State as a post-undergrad of their aerospace engineering program, conducting research on UAS electric motors. Her responsibility at this competition is to oversee the competition team and operations, as she has the most experience. This is Stephen Schmidt. He is a safety pilot for the development and competition team this year. He is a senior in the aerospace engineering program at Kent State, and this is his first year participating on the Kent State drone team. Stephen has been building and flying model aircraft since he was a kid. During the competition, his responsibilities will be to keep his eye on the UAS for the entire duration of the flight, and he will be ready to do manual takeover in case of an emergency. This is James Davis. He is the ground control operator for the team this year. He is a sophomore in the aerospace engineering program at Kent State, and this is his first year participating on the Kent State drone team. His responsibilities at the competition are to monitor the ground control station before, during, and after flight. He will build and modify flight plans as necessary to avoid stationary objects. This is Brendan Evans. He is a junior in the aerospace engineering program at Kent State. Brendan helped found the Kent State drone team last year as the team lead. His responsibilities at competition are to assist the RPIC and with other operations. This is Cole Dyer. He is the safety officer this year. He is a freshman in the aerospace engineering program at Kent State. During test flights, Cole leads safety checks prior to flight to ensure safety protocols are followed, and he will continue to do so at the competition. The platform purchased for this year's competition is the Flash, which is a modified turret X6 hexacopter configuration. The motors selected are KDE 5215XF 220 kV with KDE XF UAS 75 HVC ESCs. These components paired with 15-inch props and two 6S LiPo batteries will provide the team with the necessary thrust and weight needed to complete the competition tasks within 30 minutes. The Pixhawk Cube was selected as the autopilot for this year's drone, as there is a plethora of online technical support resources for this component. Also, a Raspberry Pi will be used to trigger the camera and possibly stream pictures back to the ground station to obtain actionable data. Docker will be used in the interoperability system, and Mission Planner is going to be used for the ground control software. It will be used to control the aircraft, navigate around stationary obstacles, and build flight plans necessary for completing the image recognition task. The KSU team is very confident in their ability to fly their drone, the Flash, autonomously through the waypoints provided by the competition. The team is less confident in their ability to complete the interoperability and obstacle avoidance portions of the competition because those elements are still being tested to ensure there are minimal flaws. The team has low confidence in the object detection, classification, and localization portions of the competition because those elements are still in their developmental stages and need to be tested. The KSU team has been testing components as they are developed prior to implementing them onto their drone. They are confident that they will succeed at the tasks they attempt based on the testing they have completed and the testing they will complete prior to competition. When selecting motors, the team had to decide between two different motors. Both were manufactured by KDE Direct. The first motor had a higher kV, was more efficient, and was lighter. Though the first motor had great qualities, the team went with the second motor because it had a larger operating voltage range. The team wasn't confident that the first motor would provide enough flight time with using only one 6S battery. Both motors were tested using Kent State University's UAS static thrust stand to verify OEM data and to ensure adequate thrust would be produced in flight. The KSU team bench tested the drone multiple times. This allowed the team to verify system integration prior to flights. The Flash has completed a total of 30 minutes in autonomous flight. For the safety of the flight, the safety pilot will always be the one to switch over from manual to autonomous flight. This ensures that the safety pilot knows exactly what flight mode Flash is in at all times and allows for quick takeover by Stephen if needed. During the 30 minutes of autonomous flight by the Flash, 2 waypoint tests were conducted. The Flash successfully hit every waypoint entered into Mission Planner by the ground control operator. This year, because of time and skill set constraints, the Kent State team decided to continually trigger the camera during flight and manually sift through the pictures to classify them. This will be done by a 2-member team during and after the flight, utilizing the 10 minutes of post-processing time allowed by the competition rules. The team is continuing to test the system and recently completed a flight test that included all camera components attached. The KSU team has yet to test obstacle avoidance performance. However, they are confident in their abilities to simulate obstacles on practice fields in the next few weeks, and for James, the ground control operator, to get practice editing the flight plan before the flight as needed. The Kent State drone team has performed 12 flight tests. The first test exposed flaws that the team had to research and implement solutions to the problems that were uncovered. The first test flight did not go exactly as planned. In order to fix the rotation problem, the team had to adapt the motor directions to match the setup in AutoPilot. During this flight, the team flew without GPS and stabilization because there was an issue with their throttle when it was in stabilized mode. They fixed this problem by resetting the autopilot to factory settings, eliminating the throttle issue. This flight crashed due to the motors turning in the wrong direction after ESC connections were changed during testing and not returned to their initial placements afterwards. This flight test caused the team to implement a safety test prior to each following flight, where the safety pilot verified all motors were turning in the right direction prior to taking off. This was the team's first controlled flight, but the UAS switched to RTL mode, or return to launch mode, and performed an autonomous landing when they lost communication with the RC controller. To solve this issue, the connection wire that goes from the receiver to the autopilot was remade. During the first official sustained flight, Stephen was able to get more comfortable with flying the Flash. The test was conducted to verify flight time. Since the maximum flight time allowed at the competition is 30 minutes, the team wanted to verify that their platform was capable of that. This flight verified that they could get 30 minutes of flight time with a safe amount of battery power left over. During the 7th flight test, the team was testing the first, lighter set of motors and had a motor go out. Here you can see Stephen landing the Flash using only 5 motors. After this crash, the team created a better wire management system for the drone.
All right, Stephen, what happened today?
So when we were flying just a little bit ago, testing out these motors with a single battery, we had a failure in flight. What it looks like happened was the motors that we mounted on here, the hardware fell out from the back ends and caused the motor to rotate forward on the one remaining mounting bolt, which caused the propeller, as it swung by the arm, to pick up on the cord which we had strapped to the top. Hooked on one of the cords, pulled it free.
Looks like it nicked this one too.
Yeah, there's a couple of nicks
Yeah,
and
there's some
cuts,
exposed wire right there.
and just obviously caused the motor to shut itself off. So we were able to successfully land it on 5 motors. It flew surprisingly well, and we know that we can make an emergency landing with 5, but we're going to try and fix these issues so we don't have to try it again.
So you're at 30 feet. Whenever you're ready.
Switch it over now. You're 50. All right, it's
It's in auto.
in auto.
So it's going So it's about, it should be turning very soon.
There it goes. Start turning.
The team has come a long way since the initial testing, and now the Flash is a reliable UAS in both manual and autonomous modes. This is the final mission test prior to submission of the Flight Readiness Review. This test was conducted to prove that the Flash could operate efficiently and safely with the newly integrated camera components. Despite not having tested an entire mission from start to finish, the KSU team is confident in the Flash and their ability to practice the mission and hone in their skills prior to competition. After having several crashes at the start of testing, the Flash is now a well-practiced UAS, and Stephen is very comfortable flying it. Several other elements have yet to be tested on the drone during a mission, but the team is working hard to make those components competition ready by June. Overall, the team is confident in their ability to work together and face challenges, and have test flights to prove that. Though the team does not have high confidence in completing all the tasks to their full potential, the Kent State drone team is confident in conducting safe flight operations. They believe that they set a solid foundation to move forward in this competition in the future. The team is very proud of what they've accomplished in 4 months with 7 members, and they are looking forward to competing in the competition this year and in the years to come.